You hear a lot about melting ice and changing climates, right? Well, in this explainer, we're going to take that idea to the absolute staggering limit. We're diving straight into the hard, scientific data of an ultimate worst-case melt scenario.
What would Earth look like if every piece of land ice suddenly disappeared? It's an absolutely terrifying premise. But, the science behind it, it's incredibly real.
So here's the number. If all the glaciers and ice caps on Earth were to just suddenly melt, global sea levels would rise by about 70 meters. That is almost 230 feet of water. Just imagine a 20-story building completely submerged. It's mind-blowing. But to understand how we actually reach that massive number, we really need to look at how this ice works.
Which brings us to the first big concept: land ice versus floating ice. This is a crucial distinction.
Because, as it turns out, not all ice is created equal when it comes to the ocean. Land ice includes ice sheets and alpine glaciers that are resting solidly on bedrock, meaning they're currently sitting on land, high and dry above sea level. Floating ice, on the other hand, includes sea ice, ice shelves, and icebergs that are already out there. They're actively floating in the ocean and already displacing water.
And this distinction matters deeply. NASA scientist Kelly Brunt actually has a brilliant way of putting this. She says, floating ice is like an ice cube floating in a glass. It doesn't overflow the glass when it melts. But when non-floating ice is added to the ocean, it's like adding more ice cubes to the glass, which will cause the water level to rise. Hit the nail on the head, right? So this 70-meter scenario we're talking about, it's driven entirely by ice that is currently locked up on land.
That brings us to our main culprits, the polar ice giants. You see, the fate of our coastlines doesn't actually rest on a few scattered mountain glaciers. It rests almost entirely on two colossal, ancient ice sheets at the literal ends of the Earth. Get this, over 99% of all the freshwater ice on our entire planet is locked away in just two places, Antarctica and Greenland. All those other 200,000 global glaciers combined, the ones we usually see on the news, they make up less than 1% of the total.
So how do these two giants translate into that massive 70-meter total? Well, if the entire Antarctic ice sheet melted, it would contribute a staggering 60 meters, or 197 feet, to sea level rise all on its own. Greenland? That adds about 7.4 meters, roughly 24 feet. And all those other 200,000 mountain glaciers? Just about half a meter. So yeah, Antarctica and Greenland hold the absolute keys to our global coastlines.
Now let's look at the anatomy of a melt.
Because ice this massive doesn't just melt like an ice cube dropped on a hot sidewalk. It undergoes this highly complex, multi-layered process. Basically, it's a double threat from above and below. First, you have warming air melting the surface. This meltwater then literally bores holes down through thousands of feet of solid ice straight to the bedrock. Meanwhile, deep below the surface, warmer ocean currents are melting the ice from underneath. This weakens the entire structure, leading to massive chunks breaking off, a process called calving. Another NASA scientist described it perfectly. It's like pointing a hairdryer at an ice cube that's also sitting in a warm pot of water. The attack is coming from literally all sides.
Let's move on to the real human impact: vanishing coasts and cities.
So what exactly does a 70-meter sea level rise mean for the places we actually live and work? The data from the U.S. Geological Survey is uncompromising. A 70-meter rise doesn't just flood a few basements. It reshapes the entire world map. This scenario would permanently submerge New York, Miami, New Orleans, and quite literally every single coastal city on the planet. The coastlines we recognize today, completely erased.
But here's the thing. Sea level rise is really only part of the story. What happens besides rising waters? The hidden systemic effects of this much ice melting are arguably just as profound as the flooding itself.
To really understand this, we just need to look at what's already happening right now. Over just the last 25 years, Antarctic ice shelves have lost a staggering 6,000 gigatons of ice just through thinning. That is a massive, almost incomprehensible volume of cold fresh water being dumped straight into our salty oceans.
And when you dump gigatons of cold, fresh water into the sea, you fundamentally alter the environment. As the ice melts, it leaks trapped nutrients, which totally changes local ocean life. But more importantly, that massive influx of fresh water actually disrupts major ocean circulation patterns. And since ocean currents act as the engine for our global climate, altering them means fundamentally changing the climate system of the entire planet. The effects ripple way, way beyond the coast.
But before we panic, let's look at a slow, long-term reality.
You see, before we assume the map is being redrawn tomorrow, we have to ground this extreme scenario in strict, scientifically accurate reality. While ice loss is rapidly accelerating in the present day, complete collapse is a slow-motion transformation. The science shows that major catastrophic changes, like the potential collapse of parts of the West Antarctic ice sheet, operate on a timeline of 200 to 1,000 years. This isn't some overnight Hollywood disaster. It's a slow, multi-generational reshaping of our world that happens over centuries.
So if we look far enough into the future at this ultimate melt scenario, what is the final takeaway we're left with? Earth would still exist, but its coastlines and climate would look dramatically different. The ice is melting. The only question left is, how much time do we have to adapt?